Alright, welcome to HVAC lesson number 5. In the previous video, we went over the wiring for my Fedder's weather wheel, and we also showed the fan motor wiring. Well, in this video here, we're going to find out why my Fedder's fan motor had failed. So I learned a tech when I took apart a bench grinder because the motor had failed. It's a very, very similar problem, except the motor I was working with at Tech was a 3-phase motor. My Fedder's fan motor is a single-phase motor, and we're going to find out why it failed. So what we're going to do before we start off here is we're going to test it the same way we did at Tech. We're going to test the leads, see if they're shorted, and then what we're going to do, so obviously if you take a listen here, you can see I have to pull the shroud back just a little bit like that. So I don't know if you just saw the camera move, but we're going to have to move the shroud back a little bit so I can spin the fan motor by hand very slowly, and we can see for sure whether or not it had failed. So anyway, I'm looking forward to that, so let's just dive into it. So for this test, I don't have as much room, so I can't put you too close. Actually, maybe I can put you as close to the motor. Let me see here if I can do that. Alright, I guess that'll have to work. Alright, so you guys can see the fan motor right there. So what we're going to do is we're going to bring in my electrical meter again. And what we are going to do is I'm going to keep it set the way I have it, which we're going to have it set to ohms. Alright, so right now we currently have it set for ohms. So what we're going to do is we're just going to test the leads first to see if they're shorted. So anyway, I've got my black, my red, and my orange leads ready to be tested. So we're going to go ahead and test them now. So I know you guys can't see my meter, and I'm sorry about that. But I will tell you what leads we're going to test. So in this case, we're going to test all possible pairings. So first thing we're going to do is we're going to test black to red, which is start to low. So if I take a look, okay, so what we're going to do here is we're going to see if we can straighten them out a little bit here, though I can get a solid reading. Okay. Alright. So it looks like we have a problem here with our first test here. We're getting a jumping ohms reading. And in this case we're getting mega ohms, guys. So that's not good. So on black to red, we have a short in the main winding of the fan motor. As I just saw on my meter what had happened, so I'm going to do this again. I'm going to go ahead and test it again. And what we're seeing oh, here we go, guys. Never mind. We have a reading of 2.4 or 2.5 ohms, which is pretty steady. So in this case, I just had to readjust the wires and get them solid for the test. So we're getting a 2.4 to 2.5 ohm reading, which is actually pretty decent. So we're going to go ahead and test black to orange now, which is, start to high. So we're going to do the same thing we just did before. So I'm just going to move those for a minute. Let's see, are we getting a reading? Alright, we should be getting a reading here. Whoa! Alright, guys, I don't know. Looks like we got a problem here. Alright, guys, that's bad. We're looking at a problem here, guys. We're getting a jumping reading, which is a short. So in this case, we do have a short on high on start, which is not good for the fan motor at all. So now what we're going to do is I'm going to hold my 2 leads here. And what we're going to do is I'm going to move the fan motor while I'm performing this test, and we're going to see what's going on here. So what I'm going to do is I'm going to see if I can rig my leads so that they stay put during the test. And now what I'm going to do is I'm going to see if I can hold. So now what I'm going to do is I'm going to rotate the fan motor. In this case, my reading is changing quite a bit, which is not good. So as you guys can see there, we've definitely got a problem with the motor. So as I turn the fan manually by hand, unfortunately I am seeing a short occur. So that's how we know one of the legs on the motor had gotten knocked off. So what happened is because the one winding is busted, I just got negative readings on my multimeter, which is not good for the motor at all. So that means a phase has gotten, a rotation cycle had gotten knocked off the motor, which the run capacitor had failed, and it caused one of the windings to burst, and it caused a short to ground in the motor, which I am going to show you guys how to, and of course, it ended up going to open line, which means there's a short in the motor, which I'm going to show you how to test the motor for a short. So we're going to go ahead and put my leads back down here after a confirmation here had occurred. So now what we're going to do is we're going to test the motor itself. So in this case, what I'm going to do here is I'm going to grab something flat. I'm going to grab something flat and non-conductive, and we're going to clean. In this case, I'm going to use an insulated screwdriver, and I'm not going to scrape this here. I'm just going to gently wipe it. I'm going to wipe it to clean it off a little so we can test the motor for a short, which we already know a short had occurred because it ended up tripping a breaker. So what I have gone ahead and done is I've cleaned the motor a little bit. So now I'm going to go ahead and take my leads, and we're going to test the motor for a short to ground. So in this case, I'm going to touch some bare metal on the air conditioner. So in this case, we're going to touch here. I'm going to touch near the control panel and the motor. And let's see if we get anything. Alright, so we've definitely got a problem here. I'm going to show you guys. So we're going to go ahead and get on one of the windings here. Alright, so I'm getting an open line reading, which means the motor has shorted to ground. So unfortunately, guys, we saw what had happened there. My Fetters fan motor had shorted to ground. Because if I get an OLOL reading, usually that means it's good. But in this case, we got a problem with the motor. So if we are going to test it, so what I'm going to do here, guys, is I'm going to do one of the speed leads here, which in this case I'm going to do high. And what I'm going to do, now only do this with the power turned off or it being unplugged, is we're going to test the speed winding. We're going to test the speed lead here, and we're going to test the metal. Let's see if it's shorted. Alright. Just like that, I'm going bare metal. Okay, so, oh well there. So it's a short in the motor itself, which had caused a short to ground in the first place. So anyway, guys, I hope you found this one useful as always. I appreciate hearing your guys' feedback. As I said before, we had just tested the fan motor and found out it's a short to ground. And also a winding had gotten knocked off, which caused a short. So anyway, guys, that's what caused the fan motor to suffer a burnout. Unfortunately, the one winding did explode. But now that we've tested the motor, we have found out it's faulty. So anyway, guys, what we're going to do is we're going to rewind it. But in the meantime, we're going to try to find a separate stator and windings to put in the original housing. You know, because I want to find a same size stator with same size windings, even if it is newer, and that's the same amperage as the original motor. So in this case, you know, we're going to try to find that out. I'm going to see if there's information on it. So hopefully I should be able to get you guys the information for the motor. That way, you know, if any of you guys know like a potential parts source, you know, please inform me which part source it is, and we'll see if we can get a fan motor for that. We see if we can get some parts for the fetters. But anyway, hope you found this video useful as always, and peace out.